Hello students, now we'll be starting the chapter electric current where I'll be solving NCERT questions for you. All the problem solving questions will be done for you. Please see to it very carefully. If you see example number 12.1, you'll find that a question is given. A current of 0.5 ampere is drawn by a filament of an electric current for 10 minutes. Find the amount of electric charge that flows through the circuit. Current is given, I is equals to 0.5 ampere and time is given 10 minutes. 10 minutes means how many seconds? 600 seconds. So we know the formula is current is equals to charge per unit time. So if you want to find out the value of charge, so your charge will be Q is equals to I multiplied with T. So I is given in the question and time T is also given in the question. I is 0.5 ampere and time is 600 seconds, right? So the right answer for this question will be 300 coulomb. So 300 coulomb is the charge which will flow through the circuit. Now let us move to the next question. So we will now see example 12.2 where it says that how much work is done in moving a charge 2 coulomb across the 2 points having potential difference 12 volt. So charge is given to you, Q is equals to 2 coulomb and potential is given to you 12 volt. So we know that potential is nothing but your work done per unit charge. So your work done they are asking you to calculate. So work done will be potential multiplied with the charge. So potential is 12 and charge is 2. So the right answer is 24 joule. So 24 joule is the correct answer for this question. Now let us move to the next question. So just below that you will find a box where there are questions. 3 questions are there, out of which one question is saying that number 2. What is meant by saying that the potential difference between the two point is 1 volt? It means that 1 joule amount of work is done in bringing a charge of 1 coulomb from infinity to that point. Okay, there is one more question, that is question number 3. How much energy is given to each coulomb of charge passing through a potential of 6 volt? Okay, passing through a battery, you can say 6 volt battery. Now, how do you solve this question? You need to find out energy, means you need to find out work done. So we know work done potential is equals to work done by charge. So work done is equals to potential into charge. So potential is 6 volt and charge is each coulomb, you can take 1 coulomb, so it will be 6 joule. 6 joule is the correct answer for this question. Now let us move to the next question. Now we will see example number 12.3 based on Ohm's law, where there is a question called how much current will an electric bulb draw from a 220 volt source? You need to calculate the current from a voltage source of 220 volt, and in the question they are saying that if the resistance of the bulb filament is 1200 ohm. So resistance is given 1200 ohm. Okay. So how do you solve this one? This is the first part of the question A. So V is equals to IR according to Ohm's law. Ohm's law. So I will be equals to V by R. Your V is 220 volt divided by resistance is 1200. So just calculate the value, that will be your current. So your current will come out to be approximately 0.18 ampere. This is for question number A. Now if you move to question number B, it's saying that how much current will an electric bulb coil draw from a source of 220 volt if the resistance of the heater coil is 100 ohm. Now voltage in question number B, voltage remains same, that is 220 volt, but resistance is 100 ohm. So again you will be using V equals to IR. So your I will be equals to V by R. V is 220 divided by 100. So the right answer is 2.2 ampere. This is the solution of question number 12.3 A and B. Now let us move to the next question. The next question says, okay, the next question says that the potential difference between the terminals of an electric heater is 60 volt, that is 12.4. Potential difference is given to be how much? V equals to 60 volt. Fine. And when it draws a current of 4 ampere, current is given to be 4 ampere, that is the current. So it is asking you what current will the heater draw if the potential is increased to 120 volt. Now if the potential, if V1 is this much and V2 is how much it is given in the question, it is saying that it is increased to 120 volt, how much current it will draw. First of all, from here we will find out the resistance, right. So the resistance from here will be V equals to IR. So R is equals to V by I. V is 60 by 4. So 15 4 just 60, that is 15 ohm. So 15 ohm is your resistance. Now we will apply here again Ohm's law. So V is equals to IR, that is V2 is equals to IR. This was V1. So V2 is 120 divided by resistance is how much? 15 is equals to I. So your current will be how much? Just check for it. It will be 8 ampere. So your current is coming out to be 8 ampere for this question. So I hope the solution part is clear to you. Now let us move to the next question. Now if you move to the next question, that is example number 12.5, it is saying that resistance of a metal wire of length 1 meter. The length is given to be 1 meter, that is the given. Length is given 1 meter is 26 ohm. Resistance is 26 ohm at temperature 20 degrees Celsius. It is how it is. Length is 1 meter, resistance how much? 26 ohm at temperature 20 degrees Celsius. If the diameter of the wire is 0.3 millimeter, diameter of the wire is 0.3 millimeter, that means the diameter millimeter, if you convert it into meter, 0.3 into 10 to the power minus 3 meter, it will be 3 into 10 to the power minus 4 meter. If I shift this point to the other side, dividing by 10 and multiplying by 10, you will get this. So the diameter is also known to you. Question is asking what will be the resistivity of the metal at that temperature. Now what is the formula for resistivity? Resistivity is equals to RA by L, right. So R is given to you 26, area, that is the cross sectional area, pi r square, pi r square. So if I make it R, so R will be d by 2, that is the radius, it will be 1.5 into 10 to the power minus 4 meter. So 1.5 into 10 to the power minus 4 whole square. Fine. And L is given in the question 1 meter. Once you solve this one, the right answer for this question will be, that is your resistivity, 1.84 into 10 to the power minus 6 ohm meter. This is the right answer for this question. So what you have done, you have calculated resistivity, but mind it, only the diameter was given to us. So from there we have calculated radius and the area, that is the cross sectional area, will be pi r square. Now let us move to the next question. A wire of given material, that is 12.6, a wire of given material having length L and cross sectional area A has a resistance of 4 ohm. Suppose a wire I have whose length is L and cross sectional area, that is this area is A, has got resistance R is equals to 4 ohm. We know resistance can be written as rho L by A, which is equals to 4 ohm. Fine. Now in the question again it is saying that what would be the resistance of another wire of the same material having length now L by 2. Now we need to calculate the resistance. I have another length which is L by 2 and cross sectional area is twice of this, cross sectional area is twice of A. Now for this one the resistance expression will be R is equals to rho L by 2 divided by twice of A. So it will be rho L by 4A. But rho L by A, if you see equation number 1 is nothing but your 4 ohm. So you can write down out here is 4 divided by 4. So the right answer for this one will come out to be, if you cancel it out, the new resistance R2. If this is R1, R2 will be, sorry, not 1 meter, unit is ohm. So it will be 1 ohm. Now let us move to the next question. The next question is example number 12.7. It says that an electric lamp whose resistance is 20 ohm. Let me write down given. Electric lamp whose resistance is 20 ohm, fine, and a conductor of resistance, and the resistance of the conductor is given to be R2, let me take, that is 4 ohm. The circuit diagram is shown in the question. The circuit diagram is somewhat like this. If you see the diagram, an ammeter is connected here to calculate the current. So current always flows from the positive terminal to the negative terminal of the battery. The resistance of this one is given to be 4 ohm and the resistance of the bulb is 20 ohm, right. So this is how the question says. Now the in the question they are asking you that calculate the total resistance of the circuit. The total resistance, these two resistances, the resistance of the bulb and the external resistance, are connected in series. So R1 plus R2, R1 is 20 plus 4, it will be 24 ohm. So we know the total resistance. Now again they are asking another question, the current through the circuit. We need to calculate how much will be the current through the circuit. If you use Ohm's law, V is equals to IR. So your I will be equals to V by R. V is given in the question, that is 6 volt. So 6 divided by 24, that is 1 by 4. So it will be 0.25 ampere, right. So 0.25 ampere is the current flowing in the whole circuit. Now again they are asking another question. This is question A, effective resistance, question B, and now we will move to question C. Question C, they are asking find out the potential difference across the electric lamp, only the potential difference out here. This potential difference you need to calculate. So how do you calculate the potential difference? So number 3, that is C, we know again Ohm's law, if you use, V is equals to IR. I we have already calculated, that is 1 by 4, that is 0.25 multiplied with the resistance of that lamp. Resistance of that lamp is how much? 20, because we have to just find potential difference across that lamp. So it will be 5. So the right answer is 5 volt. This is how you can do this numerical. Little long numericals, 3 are there at the same numerical. So please see to it very nicely. Now let us move to the next question. So we will see example 12.8 now in the circuit given in the figure 12.10. If you see the question. So 12.10 is the circuit diagram, which I can tell you is like this. This is the circuit. Where the current is flowing from positive to the negative terminal. The value of the resistance is given to be 5 ohm, 10 ohm and 30 ohm. 5 ohm, 10 ohm and 30 ohm. Fine. So, which is connected to a battery of 12 volt. In the first step it is asking that across 5 ohm, 10 ohm and 30 ohm how much will be the current. As we know that this is in parallel, so their potential will be same in all of them. Here also 12 volt, here also 12 volt, here also 12 volt. They are sharing the same points, right? So we'll use Ohm's law. At first we'll see for 5 ohm. We'll use the formula V equals to IR. I will be equals to, that is I1, V by R. V is 12, R is 5, so it will be 2.4 ampere. I1, right? Now if you check for I2, across which resistance? 10 ohm resistance. V equals to I2 R, so I2 will be equals to V by R. V is given to be 12 volt, R is 10, so it will be 1.2 ampere. Last but not the least, it is 30 ohm. 30 ohm is again V equals to I3 into R, so your I3 will be equals to V by R. Your V is how much? 12 and R is 30, so you will get 6 2 times, 6 5 times, it will be 0.4 ampere. Now you have I1, I2 and I3. So your total current will be, I will be equals to I1 plus I2 plus I3. I1 is 2.4, I2 is 1.2 and I3 is 0.4. So the right answer for this question is 4 ampere. This is the total current flowing through the circuit. So 4 ampere, here also 4 ampere, emitter will read 4 ampere, but across these 3 resistance the current will be different, which we have calculated. For this one I1, I2 and for this one I3. Now they are also asking find out the total resistance. These 3 resistance are connected in parallel, so your total resistance, that is parallel combination, is 1 by RT is equals to 1 by R1 plus 1 by R2 plus 1 by R3. R1 is 5, R2 is 10 and R3 is 30. Now if you start taking the LCM of this one will come out to be 30. So it will be 6 plus 3 plus 1, which will be 10 by 30. So cancel it out, 1 by 3. So 1 by RT is equals to 1 by 3. So the total resistance out here will be 3 ohm. So 3 ohm is the total resistance. This is how you can solve this question. Now let us move to the next question. So if you see example number 12.9, it says that in the figure, a figure is given in the question actually. So if you draw the figure, it is somewhat like this. I am following the screen. So figure is here in this way. Look at the figure. An emitter might be connected somewhere here, emitter, to calculate the current. The value of R is given, that is R1, R2, R3, R4 and R5. The value of R1 is given to be 100 ohm. The value of R2 is given to be, the value of R1 is given to be 10 ohm. It's not 100, it's given 10. So, and the value of R2 is given to be 40 ohm. This is 40 ohm. Value of R3 is given how much? 30 ohm. R3 is 30 ohm. Value of R4 is given 20 ohm. And value of R5 is given 60 ohm. And it is connected to a 12 volt battery. The battery is 12 volt. Now you need to calculate the total effective resistance and the total current in the circuit. So effective resistance for these two are in parallel, right? So if I take, 1 by Rp is equals to 1 by R1 plus 1 by R2, both are in parallel. So it will be 1 by 10 plus 1 by 40. So it will be 40 plus 10, 40 into 10. So 50 divided by 40 into 10. So 0 0 get cancel out. So the right answer 5, it is 8 times 1 by 8. So your RP is 8 ohm. So this combination out here you are getting it to be 8 ohm, right? Now calculate for this one. Okay. So again 1 by RP is equals to 1 by 30 plus 1 by 20 plus 1 by 60. So if you take the LCM and find it out, so your RP dash will come out to be 10 ohm. Therefore, the total resistance, that is RT, will be equals to RP plus RP dash. So RP we have already calculated 8 plus 10, it will be 18 ohm. See why I have taken addition. This is and this combination will be now in series, because if you minimize the circuit will be in this way. This is and in this way. So this is your 8 ohm and this is your 10 ohm. Now these two are in series. So final resistance is 18 ohm. Now they are asking you to find out the total current. You will use Ohm's law. Ohm's law is V equals to IR. I will be equals to V by R. Your V is given in the question, that is 12 volt, and your R you have already calculated, that is 12 plus 10, 8 plus 10 is 18. So 2 times, 3 times. So 0.66 ampere is the total current in the circuit. So this is how you can calculate the effective resistance and the total current. Now let us move to the next question. Question is saying that if you go to just next after the example, you will find a box where you will find 5 questions. All are numericals, all are problem based questions. First question saying that judge the equivalent resistance when the followings are connected in parallel. What are the things which are connected in parallel? Number A, they are saying 1 ohm and 10 to the power 3 ohm are connected in parallel. 1 on 10 to the power 6, sorry not 3, 6. And in the second case 1 ohm and 10 to the power 3 ohm are connected in parallel, and along with that 10 to the power 6 ohm are connected in parallel. So how you are going to solve? For first one, number A solution. So 1 ohm and 10 to the power 6 ohm. So how you will take 1 by RP is equals to 1 by 1 ohm plus 1 by 10 to the power 6 ohm. So your answer will be what? So it will be 1 plus 1 by 10 to the power 6. Fine. So if you take LCM, it will be 10 to the power 6, 10 to the power 6 plus 1. So your RP will be 10 to the power 6 divided by 10 to the power 6 plus 1. This is the resistance in parallel for this two. Now for this one, number B, it will be like this: 1 ohm, then 10 to the power 3 ohm and 10 to the power 6 ohm are connected in parallel. Again you will take 1 by RP will be equals to 1 by 1 plus 1 by 10 to the power 3 plus 1 by 10 to the power 6. So how you are going to get? So your LCM will be 10 to the power 3 multiplied with 10 to the power 6. So out here you will get 10 to the power, it's multiplied, no, so the power will be added. So 10 to the power 9 plus 10 to the power 6 plus 10 to the power 3. So ultimately you will get your RP to be, RP will be 10 to the power 9 divided by, you can take common also from here. If I take 10 to the power 3 common, it will be 10 to the power 6 plus 10 to the power 3 plus 1. So, this is how you are going to get the answer for both of them, right. Now, let us move to the next question, that is question number 2. An electric lamp of 100 ohm, a toaster of resistance 50 ohm and a water filter of resistance 500 ohm are connected to a parallel to a 220 volt source. An electric lamp of 100 ohm, and then it is saying a toaster of resistance 50 ohm and finally a water filter of resistance 500 ohm are connected in parallel with a voltage source is given to be how much? Voltage source is 220 volt. 220 volt, positive, negative. Now, they are asking you to find out what is the resistance of the electric iron connected to the same source that taken as much as current as 3 appliance. What is the current through it? That means you have to calculate the equivalent resistance. So, equivalent resistance, how will you going to calculate? Again, you will use the formula 1 by Rp will be equals to 1 by 100 plus 1 by 50 plus 1 by 500, right. So, if you calculate this one, you will find the value of Rp. I want you to solve the answer for this one, just you have to take the LCM and find the answer. And finally, if you want to calculate the current, V will be equals to IR. So, your I will be equals to V by R. V is given in the question 220 volt and your R will be calculated from here, that is Rp. Just put the value, you will get the answer in ampere. So, this is how you can solve this type of question. Now, let us move to the question number 4. Question number 3 is a theory based question. Now, question number 4 is a problem based question. Let us move to question number 4 now. How can 3 resistors of resistance 2 ohm, 3 ohm and 6 ohm, that is number 4, in the same question box, you are giving 3 resistance, that is 2 ohm, 3 ohm and 6 ohm. These are the 3 resistances given to you. How do you connect these 3 resistance so that you get at once, that is at number A 4 ohm and number B you get 1 ohm. What will be the connection of this resistance? How when the equivalent of this one will be 4 ohm and 1 ohm. So, if you want to get 4 ohm, how you are going to connect? Let me show you. 2 ohm here and other 2 are in parallel, that is 3 ohm and 6 ohm. So, just calculate out here, this parallel combination will be 1 by 3 plus 1 by 6. So, 6, 2 plus 1, that is 1 by 2. So, your 1 by Rp, so P will be equals to, Rp will be equals to 2 ohm. So, this whole combination is coming out to be 2 ohm. So, 2 ohm and 2 ohm will give you how much? Now, it is in series, it will be 4 ohm. Now, how can you get 1 ohm? For number B, if you connect all of them are in, if you connect all of them in parallel, that is your 2 ohm, 3 ohm and 6 ohm, right. Now, just check 1 by Rp will be equals to 1 by 2 plus 1 by 3 plus 1 by 6. LCM will be 6. So, it will be 3 plus 2 plus 1, that is 6 by 6, which is 1. Therefore, Rp will be equals to 1 ohm. So, this is how you can connect this type of question, right. Now, let us move to the next question, that is question number 5 in the same box. So, question number 5, before starting, I want to tell you one thing. When the resistance increases, when they are connected in series, when you add them up, right. Now, when the resistance decreases, when they are connected in parallel, right. So, in the next question they are asking what is the highest and the lowest resistance that can be secured by the combination of 4 coil of resistance. You are giving 4 resistance, that is 4 ohm, 8 ohm and then it is given 12 ohm and 24 ohm. Now, in order to get the highest resistance, highest resistance, you have to connect all of them in series. Then only they will add up and give you the very high resistance. If you add them up, how much you are getting? 48 ohm. The resistance will increase. For lowest resistance, you need to connect these resistances in parallel, so you will get the lowest resistance. So just connect them in parallel and take the combination of this one, you will get the right answer for this one. This is how you can solve this type of question. Now let us move to the next question. An electric current or an electric iron, actually this is example 12.10 of the same chapter, electric current. These questions which I am going to teach you now will be based on heating effect of current. Okay. The first question says that an electric iron consumes energy at a rate of 480 watt. Okay. Energy at a rate means power. Given the power is equals to 840 watt, right? When heating is at the maximum rate, when they are heated in the maximum rate, this much amount of power is generated, and 360 watt when the heating is at the minimum rate. This is P1, this is maximum, P2 that is minimum, it is coming out to be 360 watt, that is minimum. Now you need to calculate the current and resistance in each of the case when the voltage is supplied to both of them is 220 volt. 220 volt is given to both of them. Now how we are going to solve? We know P is equals to VI. So P1, so your I1 will be equals to P1 by V. P1 is 840 for maximum and this is 220. Now I1, if you are going to calculate, it is going to come 3.82 ampere. This is my I1. Similarly, if you calculate the resistance now, we will use the formula Ohm's law, that is V is equals to IR. So R will be equals to V by I. V is given to be 220 and your I is 3.82. Now just divide it and you will see that your right answer for this one is 57.60 ohm. This is the right answer coming for this question. Okay. Now for minimum rate, P2, again P2 is equals to VI2. So I2 will be equals to P2 by V. So P2 for minimum is given to be 360 watt and voltage is same 220. So your right answer for this one is coming out to be, if you calculate I2, 1.64 ampere. From here only it will come. Now once you know I2, you can find out the resistance. How you will find out the resistance? You will use the Ohm's law, V equals to IR. So R will be equals to V by I2. So V is 220 by I2 is 1.64. So the right answer for this one is 134.15 ohm. So two resistance R1 and R2 and two current I1 and I2 has been calculated for this question. Now let us move to the next question. 12.11. Now this is the next example. In this example they are asking a question that 100 joule of heat is produced each second. So your heat is produced 100 joule and time t is equals to 1 second at each second for a resistance of 4 ohm. Fine. Find the potential difference across the resistor. Now how you are going to solve this one? For that you need to calculate I first. I is equals to root over of H divided by R into T. This is the formula, comes from heating effect of current. So H is given 100, R is 4, time is 1, which will be root over of 25, and your current is coming out to be 5 ampere. So once you know current, you can use Ohm's law now. Ohm's law says V is equals to IR. So your V will be equals to R is 4, 5, 20 volt. So 20 volt is the right answer for this example or for this question. Now let us move to the next question. In the page 218, you will find some question in the box, out of which number 2 and 3 are problem based question. So let me show you number 2 and 3. In question number 2, it is saying that compute the heat generated. You have to calculate H. Compute the heat generated while transferring 9600 coulomb of charge. Charge is given 9600 coulomb of charge in 1 hour. Time is given 1 hour. 1 hour means how many seconds? 60 into 60, that is 3600 seconds. Right? In 1 hour, how many seconds are there? 3600 seconds through a potential difference of 50 volt. So V is also given 50 volt. Now we know one formula, that is heat generated is nothing but VIT, right? So V is known to us 50, current is not known to us, but current is what? Q by T multiplied with time. This time coming here, TT get cancel out. So 50 into the charge 9600. So if you solve this one, you will come out to be 5 into 6 to 30, 5 9 to 45, 48, 0, 0, 0. So you can write down as 4.8 1 2 3 4 5 into 10 to the power 5 joule. 4.8 into 10 to the power 5 joule will be the right answer for this question. Now let us move to the next question. It is saying that in that question, an electric iron of resistance 20 ohm. The resistance of the iron is given to be 20 ohm. Fine. Takes a current of 5 ampere. Current, how much it takes? 5 ampere. Calculate the heat developed in 30 seconds. Time is given 30 seconds. Right? So what you can do is, you need to calculate heat. Heat is equals to VIT. Also you can write down this one, and if you put this one as IR, it will be I square R T. If you put Ohm's law here, I is known to us 5 square, resistance is known to us 20, and time is 30. 5 square is 25 into 600, that is 600. So if you want to calculate this, the right answer will come out to be 15000. So 1.5 into 10 to the power 4 joule. This much amount of heat will be developed. Now let us move to the next question. Example 12.12, it says that an electric bulb is connected to 220 volt generator. The current is 0.5 ampere. Connected to a voltage of 220 volt and current is 0.5 ampere. Right? What is the power of the bulb? So power, simply you will use the formula P equals to VI 220 into 0.5. So 220 into half, that is 110 watt. This is the correct answer for this question. Now just below that you will find one box where there is a question saying that an electric motor takes 5 ampere. Electric motor takes 5 ampere. Current is given 5 ampere from a 220 volt line. Voltage is given to be 220 volt. Right. Determine the power of the motor and the energy consumed in 2 hours. Power of the motor you have to calculate, and energy consumed in 2 hours. 2 hours means how many seconds? 2 into 3600 second. So first power we will calculate, it's easy, VI. So 220 into 5. So it will be 0011. So 1100 watt. Fine. Now your energy can be written as VIT, that is your heat energy. V is given 220, I is given 5 and time is given 2 into 3600. So this one we have already calculated, 220 into 5, that is 1100 multiplied with, if I do this one, 12 6700. Now if you multiply this one, your right answer will be, just do it in the separate, 72 into 11, 72, 72. So 297, 792. So the right answer is 792,000. So 7.9 into 1, 2, 3, 4, 5, 6, 10 to the power 6 joule. This much amount of energy will be consumed. Right? Now let us move to the next question. Now we will be solving exercise questions. In exercise question, there is a problem solving question. That is question number 3. It's saying that an electric bulb is rated 220 volt and 100 watt. The voltage is given to be 220 volt. At that time my power was 100 watt, and when it is operated in the voltage, how much it is given? 110 volt. How much will be the power? That is what we have to calculate. As we know, P is equals to VI. Also we can write down this one as V by R. According to Ohm's law, I can be replaced as V by R. So it will be V square by R. So your R will be equals to V square by P. V is given to us 220 square divided by 100. Fine. So this is my resistance. Let me keep it in this way for this one, because P2 will be easy for me to find it out. Now again, P2 will be equal to V square by R. V we know, that is 110 whole square, and R square is 220 whole square into this 100 will go above into 100. So if I solve, I'll solving little up here because there is no space. So it will be 110 into 110 divided by 220 into 220 into 100. So now let us just cancel it out. So 100 2 times, this is also 2 times. So 100 divided by 4, which will be 25 watt. So 25 watt is the correct answer for this question. Now let us move to the next question. Now we will do question number 6 from the exercise question. A copper wire has diameter 0.5 millimeter. Diameter D is given 0.5 millimeter. Fine. And resistivity 1.6 into 10 to the power minus 8 ohm meter. Resistivity 1.6 into 10 to the power minus 6 ohm meter. This is the resistivity given. Fine. What will be the length of the wire to make its resistance 10 ohm? Resistance is given now 10 ohm. We need to calculate the length of the wire. So is it possible to calculate? Okay, fine. Now how you are going to do it? Rho R is equals to rho L by A. So you need to calculate L. L is equals to RA divided by rho. So R is given 10. A we can calculate, that is 0.5. The radius, it will be 0.5 into 10 to the power minus 3 meter. I mean the diameter. So it will be 5 into 10 to the power minus 4. So if I divide it by 2, I will get radius. Radius R will be 2.5 into 10 to the power minus 4. Now resistance is 10, area is pi r square, R is given, that is 2.5 into 10 to the power minus 4 of whole square divided by the resistivity, that is 1.6 into 10 to the power minus 6. So if you calculate this one, the length will come out. All the values are given to you now. So you just need to calculate the length. The main is the application of the formula. Formula is shown to you. Now once you know this, again they are asking in the same question, how much does the resistance change if the diameter is doubled? So if the diameter is doubled, means this D will become how much? 1 millimeter. and the other thing will remain same. This resistance will change. So once you find out the length, once the length is found out, just put the value of the length and find the resistance again. So diameter in the next case will be double, diameter will be 1 millimeter. Now let us move to the next question. Question number 8, it is saying that when a 12-volt battery is connected across an unknown resistance, voltage is given to be 12 volt, fine. There is a current of 0.2, there is a current of 2.5 milliampere. Current is produced 2.5 milliampere. Converted into ampere, it will be 2.5 into 10 to the power minus 3 ampere. Now they are asking you to find out the resistance out of it. So again you will use Ohm's law. V is equals to I R. So R is equals to V by I. So V is how much? 12. It will be 2.5, that is your current, into 10 to the power minus 3. So if you check on this one, you have to 10 to the power minus 3. If you go up, it will become 10 to the power plus 3. So this one 12 divided by 2.5. Let me take it separately. 120 divided by 25. So 120, 4 times 100, 20.0, 1, 2, 3, 4, 5, 6, 7, 8, 4.8. 4.8 into 10 to the power 3 ohm. I can say 4.8 kilo ohm. Kilo ohm. 10 to the power 3 if you convert it into kilo. So this is the right answer for this question. Now let us move to the next question. A battery of 9 volt, that is question number 9. A battery of 9 volt is connected in series with resistor 2 ohm, 0.2 ohm, resistor 0.2, many resistance are given in the question, 0.2 ohm, 0.3 ohm, 0. If you see the question, 0.4 ohm, 0.5 ohm and 12 ohm are connected to a battery of how much volt? In the question it is saying that it is connected to 9 volt. Positive, negative. Now in the question it is saying that how much current will flow through this 12 ohm. So whatever current will flow, it will flow same across all the resistor because they are connected in series. So what we will do is we will find out the combination total resistance out of it. So it will be RT will be equals to 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. So it will be 5, 9, then 1.4. If you calculate this one, it will come as 1.4. See, 0.5 plus 0.5, this one will make 0.5, so it will be 1 plus 0.4, 1.4, so it will be 13.4 ohm, right? So the current will be across 12 ohm. V equals to IR we can do. So I will be equals to V by R. V is given 9 volt and this one is 13.4. So that will be the amount of current which will pass through across all the resistance. Why? Because all are in series. The current will be same across. The potential difference will be different because the current has only one way to go, right? Now let us move to the next question. Question number 10, it is saying that how many 176 ohm resistors in parallel are required to carry 5 ampere on a 220 volt line. You need to get a current of 5 ampere in a 220 volt. 176 ohm resistors, how many has to be used so that they are connected in parallel? So what you will do, 1 by R is equals to, let us take that number is X. X be the number of resistors. So X by 176 is the ohm. So R will be equals to 176 divided by X. Now you use the formula Ohm's law again. Ohm's law. V equals to IR. V is given to you in the question. How much is the V? V is, if you see question number 10, it is 220, and I is given 5 multiplied with 176 by X. So X will be equals to 5 into 176 divided by 220. So if you cancel with 5, it will be 4. Cancel with this one. 44 into 4 times is 176. So your X will be 4. So there are 4 176 ohm resistor has to be used in order to get a current of 5 ampere through a potential difference of 220 volt. Now let us move to the next question, which is saying that is question number 11. Show how would you connect 3 resistors each of 6 ohm. 3 resistors are there, each of 6 ohm, so that you get 9 ohm. In one combination you get 9 ohm, and in another combination you get 4 ohm. So let us see for this one first. If I connect the resistance in this format, what do you think? 6 ohm, 6 and 6. So this is 6, and the combination of this one will be 1 by 6 plus 1 by 6, that is 1 by Rp, which will be 3. Rp will be equals to 3. If you take LCM, you will see that. So this whole combination is coming out to be 3. That means 6 plus 3, 6 ohm and 3 ohm. They are in series now. So the total resistance RT will be 6 plus 3, that is 9 ohm. This is how you can get 9 ohm for this one. Now let us see how can we get 4 ohm. Now we will check how to get 4 ohm. Suppose I have this resistors 6 ohm each. Both 2 of them are connected in series. One of them are connected in parallel with those 2. So 6, 6, 6. So these 2 are in series, so it will give you 12 ohm. So if you resolve the circuit, it will be like this. This is 12 and this is 6. So these 2 are in parallel now. 1 by 12, 1 by Rp will be equals to 1 by 12 plus 1 by 6. So LCM will be 12. 1 plus 2, that is 3 by 12, will be 1 by 4. So Rp will be equals to 4 ohm. This is how you can get the correct answer for this question. Now let us move to the next question. Now we will be doing question number 12. Fine. So let us see. That is of exercise question. Several electric bulbs designed to be used on a 220 volt electric supply line. So voltage is given to be, voltage is 220 volt, right? Are rated 10 watt. The power is given to be 10 watt. Fine. How many lamps can be connected in parallel? How many lamps? Lamps, how many? And we have to calculate in parallel with each other across the 2 wire of 220 volt line. So out here, when voltage is 220 volt line, fine, and if the maximum allowable current is 5 ampere and the current is 5 ampere, this is what is supplied in the question. So let me make you understand one more time. The question is, they are asking you that in a certain circuit the power rated is this much, voltage is this much, and your current is this much. So how many lamps will be connected? How many resistances, lamps resistances has to be connected so that the value of the current comes as 5 ampere. How many can be calculated from the resistance itself? Now from here, if you calculate the resistance, P is equals to V square by R. So your R will be V square by P. So your V is 220, 220 multiplied with 220, divided by P is how much? 10. So just 0 0 get cancel out. 22 into 22 you will check on the other side, that is 4 4 4 4 484. So 4840 ohm, that is the resistance of one resistors. Now in the second case it is saying that the voltage is this much and the maximum current is flowing this. So we can calculate the equivalent resistance also. From here, if I use Ohm's law, V equals to I R. So R will be equals to V by I. That will be my equivalent resistance. V is given 220 divided by 5. So if you cancel it out, it will go 4 times 4 times. So 44 ohm. Equivalent is 44 ohm. Now finally you are going to very close to get the value of the lamp. So we know 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by Rn. But out here the value of the resistor is same for each of them. This R1, R2, R3 and Rn will be same multiplied with n times. So 1 by R equivalent is given to us 44, n divided by how much? 4840. 4840. From here, if you calculate the value of n is coming out to be 110. So number of lamps required will be your 110, right? So just calculate the value of n you will get 110. Now let us move to the next question. Question number 13 is saying that a hot plate of an electric oven connected to a 220 volt. The voltage is given out here is 220 volt, and it is again saying has two resistances, coil A and B. If you see question number 13, A and B, each of 24 ohm. Both the resistances are of 24 ohm, which may be used separately, one time in series and the other time in parallel. Okay. So what will be the current in all the three cases? In first case, we will use Ohm's law everywhere. V is equals to I R. At first let us see when they are used separately how much will be the current. Resistance is given is 24 ohm. Okay. So V equals to IR, I will be equals to V by R. V is 220 divided by 24, 9.1 ampere. So the right answer for when they are connected separately, it is 9.1. So now I can tell you about when they are connected in series. So when they are connected in series, total will be 48 ohm. So again you will use Ohm's law, V equals to IR. So your I will be V by R. V is given to be 220, R is 48, right? The right answer is 4.6 ampere. Now in the third case, when they are connected in parallel, so 1 by Rp is equals to 1 by 24 plus 1 by 24, that is 2 by 24, cancel it out, 12. So Rp will be equals to 12. So again I will be equals to V by R. V is given 220, R is 12. So the right answer is 18.3 ampere. 18.3 is the correct answer. So we got three answer, I1, I2 and I3 for different connection. When they were connected separately, when they were connected in series, this is series, when they were connected in parallel. So we got the answer of all of them. Now let us move to the last question of your NCERT, that is question number 14. Question number 14 is saying that compute the power used in 2 ohm resistor. We need to calculate the power. At first they are saying of resistor 2 ohm given in each of the following circuits. The first circuit is saying that number 1, a 6 volt is in series with 1 ohm and 2 ohm. 6 volt is connected in series with 1 ohm and 2 ohm. Fine. And 4 volt is connected in parallel. This is the first case. Let us see that first. So we have to calculate the power used by 2 ohm only. So we need to find out power is equals to VI, or you can use the formula I square, sorry, if you put here I square R, right? If I put V equals to IR, it will be I square R. So I we can calculate from here, that is V equals to, we can use IR. So I will be equals to V by R. V is given 6 volt, R is 1 plus 2, 3. It will be 2 ampere. So the current across this one, whole one, will be 2 square multiplied with the resistor 2 ohm, right? So your right answer is 4 to the 8 watt in the first case when they are connected in series. Now in the second case they are saying that what will be the power when they are connected in parallel. So let me tell you, it is like this. Please note it. I will rub this one now. In the second case, that saying that two resistors are connected, that is 2 ohm and 12 ohm. They are connected to a 4 volt battery plus minus. Okay. Now you need to calculate the power across 2 ohm. See, the potential across both of them will be same, that is 4 volt. So P is equals to VI we can use. Okay. Or you can use one formula, that is V square by R. So I can use V square by R. So V is how much? V is 4 and R is 2. So the right answer for this one is also 8 watt. 8 watt is the correct answer for this question. So all the details question, all the solution, I mean to say, are being solved here on the board and you have seen. So this is a solution from the chapter, which one? Electric current. Please see the concept first and then come for the numericals part. It will be easy for you. Thank you and keep enjoying physics.